Hello. Okay, let's go into the details of the requirements analysis good practices. So we had this list. I have picked 7 good practices of requirements analysis, and in this very first video I'll be discussing about the first 2: modeling the application domain or the environment, and modeling the requirements themselves. Okay, so let's start with the first one, modeling the application environment. How can you do that thing? Essentially, we have already discussed in a previous video about that, using a context diagram. Basically, context diagram defines the boundaries between the interfaces, let's say, between the system being developed and the entities external to the system, such as the other software, such as the users, the hardware devices, and any other kind of an information systems, which is also which can be also considered as a software as well. So what happens is that, in fact, you start drawing a context diagram to identify what your scope is in the elicitation in an earlier phases of the requirements, let's say solution development, during elicitation, for instance. And as you get more information about the environment, about what really will be covered, and you have a better understanding of what the requirements are, you enhance that context diagram, or you enhance that scope, make it a little bit more concrete, update it, and in fact you continue updating it through requirements analysis, and even in the later stages of specification and validation verification. So how did it look like? So it looked something like this. I'm going to close myself here. So as you can imagine, as you see here, so we put this the solution at the center, solution IT system solution at the center of your graph, and then you define what the which users are there, what type of other systems are there, if there is any hardware component, what other hardware components that does this particular solution IT system will communicate with. And basically you just define your message exchanges, let's say, at a higher level, not at a very low level, but a higher level of what this kind of data exchange is about, type of level. Essentially this is a kind of consistency check as well, that somehow these inputs that the system will get should be processed inside the system. So this is, again, was an example of a diagram that shows how you define your scope for your in a graphical way. Obviously it does not fully cover the or represent, or let's say replace the textual description, but it complements in a very, very important and nice way. Okay, so the second best practice is modeling the requirements. How do we represent the requirements? We basically use more or less 3 ways. Now we can use a very formal way and a very informal way, like the natural language, not necessarily very informal, but let's say the least formal way would be to use natural language. And there are things in between, like semi-formal, which means using graphical representations and a natural language at the same time. So there are indeed formal ways to represent requirements as well. There are even languages like the language of Z, check it through the internet, you can use to represent requirements in a formal way so that everybody understands that thing in the right way. But of course, this is quite a labor-intensive way to define requirements in a formal language, but it gives a lot of flexibility, or let's say assurance about the completeness and consistency of the requirements. So if you're working in a mission control, development of a mission control system, I don't know, aircraft system, then it's a very good practice to use formal ways to represent requirements. But again, if you're talking about IT system that facilitates business, in many cases using both textual and graphical forms is the common way to go forward. And graphical models, okay, depicts the requirements usually in a high level of abstraction in contrast to the details shown in the requirement specification document or user interface with that a prototype provides, but they can be very helpful in coming up with, or let's say, finding out the inconsistencies, conflicts, or things that are lacking or things that are superficial about the requirements. Modeling, perhaps before I go into this modeling ways to model, let's say, let me mention about one thing. So there are, you will see, I'll discuss about ways, different type of ways, the modeling notations or conventions that you can use, but you may as well come up with your own notation, and that would be a very bad idea, for the reason that we use the graphical notations or graphical representations, again, for communication reasons. So we want that thing to be understood in the same way that to be understood by their target audience. So if you come up with your own kind of a way to represent the requirements, then you defy your own purpose. So if you really want that graphical representation to actually depict something that is understood by other parties, then you would better use a proper notation and stick with the conventions of that thing. Do not create some kind of an ad hoc representation of requirements where squares mean something, I don't know, oval things represent something else. If you're adopt a good practice would be adopt a known notation, and then stick with the notation. That is very important. So do not go ad hoc in that matter. Diverse modeling options, so many essentially. So these are, I would say, the core that you can use. We can talk about use case diagrams, UML class diagrams, UML active. Basically, UML diagrams are very, very powerful. It's always helpful to use them. It's like a kind of, they are a bunch of modeling notations that are known to be helpful, useful in conveying knowledge. State charts are examples. So I'll give examples, but I'll not go into details of how they are developed, how they are used, particularly the UML diagrams. But I would strongly recommend you to have a look at them and start using them. Okay, so entity relationship, I'll come to that later on. Data flow diagram, decision tables, decision trees. It's not just UML diagrams, but more. But particularly know these things. Know what these notations are for, and how you can use them, what are the strong and weak points. So that would be the thing that a successful business analysis should do. Okay, so again, learn particularly how to use UML diagrams. I put a link to a site which basically covers the core concepts, and I think it's quite useful at least to have a look at them. But there's a big but here. There's a big however here, if you like. So we have to be very careful in the use of these diagrams. What I mean is this. So many of these diagrams are also used to represent a solution or solution design. So there's this graphic here that shows how all these kind of requirements and design are interrelated. So we have these user requirements, and basically we are at this stage more or less at this moment, requirements analysis. We're trying to understand how, we are trying to, let's say, gather and elicit, analyze the user requirements. And user requirements have some overlap between with the solution requirements. If you remember the types of requirements, user requirements that are aimed at communicating the requirements with the users at a rather high level. And then we have the solution requirements, which are targeted mainly towards designer and the programmers, which take them they are usually often in a much more detail than the user requirements. They take those requirements as input and design the solution, and then in fact that design becomes an input also for the programmer. So this is how it goes. These are the relations. There are obviously quite a lot of overlaps between these, but user requirements, you are still in the user domain, and you must use all these diagrams with care, in the sense that you do not go into the domain of the solution. You do not start putting some elements there which belong to the solution. So you're still in the user domain. You should not dive into the solution domain and try to specify something that is basically something about an attribute or a kind of something about the design. So don't get into that one. So we are in the requirement stage, requirements domain, and you should be there. You should stick being there. I'll give examples. So for instance, class diagrams. So class diagrams, you can start using class diagrams at a very early stage to represent user requirements or data aspects of user requirements, and then you enhance them in this when it comes to solution requirements, and then you even put more material, much more detail to the class diagrams to represent the solution design. Okay, so methods and whether accesses to methods and so on, which belong to the design stage but not to the requirement stage. Okay, so know what you represent: user requirements, solution requirements, and solution design. In this course, we are interested in the user and solution requirements, but not in the solution design. Okay, so no need to go there. We are business analysts. Good. Having said that, now what I'm going to do, I'll show you a couple of model examples, and basically ask which modeling notation does this particular, what kind of a diagram would that be. Okay, so this diagram in fact shows the users, potential users, and high level, let's say, features, the things that the user will do with the system. What kind of a diagram is this? It's a use case diagram. Some of you would know it from previous courses as well. Again, this is a user, it's a very nice diagram to show the entire, let's say, features that a particular system should possess, should have at the end. How about this one? So we have lanes here, and each lane represents different type of users, and then we have activities, and then we have even in fact decision points where you have and or type of representations. Many of you are familiar with the BPMN notation. Essentially this is kind of a flow chart. This is UML activity diagram, and it can be used to, it's a representation of a control flow, whether it's a process, whether it is a way that the user uses a particular system, or whether it is it's how a particular component of a system, how an algorithm, for instance, of a system would work. So in the later, it would be a design, the specific algorithm, it would be a design. It would be used in that case to represent a design aspect, and if you're talking about a process, then you are definitely in the requirements in the user's domain. Okay, so use it carefully. UML activity diagrams. You may as well use BPMN, but BPMN is let's say at a very high level, so it has more to offer than the activity diagram. Activity diagram is quite easy to understand and use. You can as well use the BPMN basic notation set, I must add. How about this one? Essentially, this is, I have already given you the answer here. It's also a UML activity diagram, but in this case we do not use the lanes, so lanes are optional. And this is basically a process representation. In fact, you have kind of OR, XOR, and loops and so on. So it's basic control flow. How about this one? This one shows the entities that a system will manipulate. So what kind of information does this system manage? And this is a class diagram. It's a UML class diagram, and I must say that this shows perhaps much more than it should at the requirement stage. So when you have these kind of, so it shows the name of the entity, the class, and the attributes, like if you're talking about a patient class, we have ID, name, age, address, sex, and whatever. So these are the attributes of that particular class, patient. And we also have the methods to reach, and particularly the method definition belongs to the solution domain. So you shouldn't be worried about that part when you're defining, when you're analyzing the requirements. Okay, another important point, but very powerful. You should use that anyway, but with care. How about this one? Order received, unprocessed order, rejected order, accepted order, pending. So it's something about orders in this case. This is a diagram that shows how a particular class or a business object changes its state, and under what conditions or after which activities it changes its state. In this case, you're talking about an order, a business entity. So it starts when you have the order, it starts with an unprocessed, with the state of unprocessed, and then if it is rejected, after checking, it becomes a rejected order in your system. If it is accepted, it becomes an accepted order, and so on and so forth. So it shows how that particular object in your system which trajectory it should follow in the system. And that's a state diagram, or there's also a UML state diagram, or state transition diagram, or state charts. Different name exists, but basically they are all the same, with minimal differences in the conventions and the notation being used. Very powerful, very nice way, because it's kind of a unique, but it's nice. Again, what about this one? This is a UML sequence diagram, but I must add that it's mainly used for during the solution design. But it is also powerful if you use it for representing control flow. Here, what you see is like every column represents a particular, let's say in this case, a department or a unit or a role, and it shows how the information or who calls what in that particular process. It shows the control flow in a way, a control flow. So it says, like, it starts with the patient, perform checkup, and the doctor performs a checkup, and then returns prescribed medicine, and return and prescribe tests, and then the test goes to the test department, and so on. So it's another way of representing the control flow. And again, it's heavily used in the solution domain. But in this case, in the solution domain, you don't see the roles, units, organization units, but you see the components of the system, and it shows how these components, the classes of the systems, communicate among themselves for to address the needs of a particular end user. Usually you have these use cases, and you define in the requirements analysis phase, you define a use case diagram, and define using a template what a use case, but a particular use case work. And then to supplement that thing, you use UML activity diagrams or sequence diagrams. And then in this system solution design phase, you use sequence diagrams to let's say to depict how the components, how the classes exchange messages among themselves for a particular use case. Okay, enough of detail for the time being. Okay, the message here is learn how to use, so that is very, very, very important. Learn how to use diagrams, particularly those that I just given as examples. So I mean, many of you know about how to use such diagrams. Perhaps some of them are new to you, I don't know, but learn them. Okay, that's the message. And yeah, we'll continue with the good practices in the next one. Okay, good.